right, folks, 5.3, distributive property, FOIL, you may have heard before, FOIL. Starts out pretty straightforward, 178, a 6y to the 7th minus 3y to the 4th. So we're just multiplying everything. 6 times negative 3 is a negative 18. Y to the 7 times a y to the 4 is a y to the 11. And we're done. B, 4/7 rs squared times 14rs cubed. 4/7 times 14, so 4/7 times 14. You may just want to reduce. 7 goes in there once, 7 goes in there twice. And that's going to leave us with a 4 times 2, which is 8. So kind of made a mess here, but that's going to give us an 8. So the 4/7 times 14 just gives us 8. R times R is R squared. S squared times S cubed is S to the 5. Add them together. Ta-da! And then 182. Let's turn this around. Save some papers. 182. 182. Negative 8x times x squared plus 2x minus 15. So it's the negative 8x times this guy, and that guy. Just distributing it all out. Negative 8x times x squared is negative 8x cubed. Negative 8x times the 2x is negative 16x squared. Negative 8 times the negative 15 is a positive 120x. So just you see how it's the whole negative 8x times each of those three pieces. Okay. Part B should be straightforward. Okay. And then they start teaching you to FOIL. I'm going to skip that for 1 second. Okay. So I'm going to go out of order for 1 second. The foiling, some of you know foiling, so hang on for a sec. I'm going to jump to 206, and then I'm going to come back to like 186. So in general, so rather than give you the special situation of FOIL, I'm going to give you the more general idea. So in 206, we have x plus 5 times x squared plus 4x plus 3. See how it's in parentheses? This is a binomial times a trinomial. So here is what needs to happen. I need to multiply this x, the x right here, times that guy, and that guy. And then, after I do that, I need to multiply the 5. Same thing, 5 times this guy, that guy. Okay. So it's just going to make a big mess that you clean up. So let me do the x to each piece. So x times x squared is x cubed. X times 4x is plus 4x squared. X times 3 is a plus 3x. Okay, now let's do the 5 times everybody. 5 times x squared is 5x squared. Rather than put it right here, what if I kind of line things up nicely with like terms? 5x squared. 5 times 4x is a plus 20x. And 5 times 3 is 15. So I could have written this all right there. But when I'm combining like terms, you see how if everything's kind of lined up, it makes it a little bit easier? X cubed plus 9x squared plus 23x plus 15. X cubed, x squared, x, and then just constant, so no x. So descending order. This is about as good as it gets. No like terms to combine. Okay, so that's the general approach. No big deal. So now let us go back to, so using that approach, let's do problem 186. So using that same technique, we have w plus 5 times w plus 7. So same logic. The w, I have to multiply by that guy and that guy. And then the 5 has to multiply by that guy and that guy. Okay. So w times w is w squared. W times 7 is a plus 7w. Now the 5. So plus 5w. Let me just put it right here. Although before I line things up, but I'll just for some reason put it here. Plus 5w plus 35. And notice that those guys are the same. So that's w squared plus 12w plus 35. Ta-da! Easy peasy. Now, the book, every book always does this. So rather than just distribute, they think it's something special whenever you have a binomial times a binomial, and they introduce this idea of FOIL. Firsts, outsides, insides, lasts. It's fine. So we do the firsts. W times W is W squared. Outsides, see the outsides? The W and 7. The insides, okay, the 5 and the W. And then the lasts, 5 and 7. FOIL. Oh, you mean the same thing I got up here when I just distributed? Yeah, so FOIL is just distributing? Yeah, why do they teach it as something new? I don't know. W squared plus 12W plus 35. Ta-da! Okay, so I think you were cool with distributing. Special case, binomial times binomial. People like to say FOIL. No biggie. Let's see, do they get more difficult? I feel like we've done this before. I'll do one more. So occasionally they try and trick you. So this seems pretty straightforward. And then like in 216, they'll kind of give you a problem that looks different. They're like, okay, please clean up. My W's are horrible. W plus 4 squared. And you're like, well, that doesn't look like what I'm used to. And you say, oh, so you want me to W plus 4 squared, so you actually just want me to write W plus 4 times W plus 4? Okay, so one extra step. Oh, now I can distribute, or FOIL. I grew up with FOIL, so that's how I do it, but it's the same thing, right? So in my head, I'm actually saying FOIL, just because I was brainwashed. Okay. Firsts, outsides, insides, lasts. W squared plus 8W plus 16. So whatever you do, if you distribute, if you FOIL, whatever, it doesn't matter. You get that answer and we all agree. Cool. How complicated could this get? Oh, let's give you fractions. Okay. 1/5 x minus 1/7 y quantity squared. Okay, so just like I did here, let's write it as 1/5 x minus 1/7 y times 1/5 x minus 1/7 y. Okay. Firsts, 1/5 times 1/5, x times x, so that's 1/25 x squared. Outsides, 1/5 times 1/7 is 1/35 xy is an xy, so, but it's a minus, careful, minus xy over 35. Make sure you're cool with that. 1/5 x, 1/7 y, or minus 1/7 y gives us minus xy over 35. So first, outsides, insides, another minus. And then last, one negative times negative is positive. Okay, clean this up a little bit. So you have 1 over 25. So sometimes you don't put the 1 there. And so see I put this 1/25 x squared? Sometimes I'll just put x squared over 25. Arr. New pen, new pen. X squared over 25. Minus xy over 35, so that's 2 of them. Minus 2 of these xy's over 35. Does the 2 and 35 reduce? No, so leave it alone. Plus, oh, did I forget to do y times y is y squared and no one yelled at me? Oh my gosh, y squared. Okay, plus y squared over 49. Whew. Okay, hopefully that was all in frame. So again, purposely left off that 2 so that you would scream at the screen, but I brought it back. Okay. So now that you're cool with this, they like pointing out shortcuts. So let us do 228. So 5k plus 6 times 5k minus 6. You see how these things basically look alike, it's just there's a plus here and there's a minus there? So we call this conjugates. And the reason we like conjugates is because they're easy to multiply. That, and they have some interesting properties later on, but let's not worry about that. So let's just FOIL. Firsts, 5k times 5k is 25k squared. Outsides, 5k 6 minus 30 Okay, inside 6, 5k plus 30k. Lasts 6 minus 6 minus 36. So you notice the cool thing about conjugates, whenever you're foiling, outsides and insides always cancel. They have to. So you're just left with a 25k squared minus 36. Oh, that's why I like conjugates, because outsides and insides always cancel. So let's see if we have faith in that idea. So 230, you have 11k plus 4 times 11k minus 4. I have total faith in conjugates. I know that outsides and insides cancel, so let's just do first. 11k times 11k is 121k squared, and 4 times negative 4 is minus 16. Boom, done. So do you see how I just knew that negative 44k and positive 44k, outsides and insides, would cancel, so I didn't even bother because they are conjugates. Have faith in conjugates. Cool, so this is a good section, and everything's pretty straightforward. Oh, and then they try and trick us down at the very end there. Let's see, so at the end of 5.3, some functions. No big deal. So we have 278. They give us f of x is equal to x plus 2, and then they say g of x is equal to 3x squared minus 2x plus 4. And in question A, they want f times g of x. Okay, so just get familiar with what that means. That just means f of x times g of x. So f times g of x is just f of x times g of x. Okay, so just multiply those guys. X plus 2 times 3x squared minus 2x plus 4. Okay, I'll do the x times everybody. 3x cubed minus 2x squared plus 4x. Now I'll do the 2 times everybody. I'm going to line things up, so that's going to give me a 6x squared plus 4x plus 8. Add them up. Boom. 3x cubed plus 4x squared plus 8x plus 8. Done. B. F times g of minus 1. F dot g of negative 1. So basically they want us to plug negative 1 in here. So you can put negative 1 in this line, wherever you see an x, or I could just go straight to here. Right? We already cleaned up f times g of x, and now they just want me to put negative 1 into it. Okay, 3 times negative 1 cubed plus 4, negative 1 squared plus 8, negative 1 plus 8. Now I can do that because this is f times g of x, so write f times g, but instead of x, plug in negative 1. Okay, so it cleaned up to this mess. So now that we have it all done up here, now plug in negative 1. Okay, so negative 1 cubed is negative, plus negative 1 squared is positive, minus 8, plus 8. Negative 8 and 8 go bye-bye. Negative 3 and 4, give me a 1. Done! Okay. Now 5.3 is totally manageable.